Hello everyone, welcome to Artistic Atom channel. I'm Fatima and this is part 2 of organic reaction series. In this session we will cover the last addition reaction which was left, and also we will cover free radical substitution reaction. So let's get started. Now, the last addition reaction in case of alkenes is addition polymerization. What do you mean by the term polymerization? Well, the name itself suggests that there is a small unit which repeats itself and get added and combined together via chemical bonding to form a compound with huge molecular size. And to that compound we call it as what? Polymer. Okay, because it consists of n number of the same small repeating units. Now here I have taken an example of ethene. As you can see, here is the ethene, and as soon as it undergoes a polymerization process, this same unit repeats itself n number of times and result in the formation of huge molecular size compound, to which we call it as what? Polyethene, as you can see over here. And in day-to-day life also we use this compound in polythene. Okay, the polythene bag that we use, it is made up of this polymer. Now let us understand the mechanism behind this polymerization reaction. So, well, polymerization reaction follows a free radical mechanism. So, hence we know that in free radical mechanism, we always require an initiator which can initiate the reaction. So, as an initiator, we use peroxide. So, peroxide molecule undergoes a cleavage, which is nothing but a cleavage is nothing but the bond breaking. Okay, and this bond breaking is nothing but homolytic fission. Okay, or homolytic cleavage. What do you mean by the term homolytic fission? Homo means same, okay, and fission means breaking. So as we can see here, we have both the atoms of same electronegativity. As they have same electronegativity, so when I break this bond, one electron goes to this oxygen and one electron goes to this oxygen, and it results in the formation of a neutral species, to which we call it as what? Free radical. Now, this free radical is very reactive in nature, and it attacks on these ethene molecules and initiate the reaction. So as you can see over here, as soon as this free radical comes in contact with this ethene, it results in the breaking of this pi bond. As this pi bond breaks, one electron goes and combines with this one electron and results in the formation of oxygen carbon bond, and this one electron left unpaired over here. And as you can see, this is another free radical. Now this reaction continues itself till the time whole reactant, that is the amount of ethene present in the system, get exhausted and result in the formation of this huge molecular size compound, to which we call it as what? A polymer. So this is how actually a polymerization reaction happens. Now, this is the conclusion of this whole mechanism. So, addition polymerization consists of three main steps in free radical mechanism. First is the initiation step, where we use a peroxide as an initiator. Then the second step is the propagation step. Here, what happens is the homolytic fission. Due to this homolytic fission, it results in the bond breaking, and what happens? These molecules, they attack on the other molecules present in the system and cause them to combine with each other chemically. And this process continues until the whole reactant is exhausted, as you can see over here. Now, the last step in this mechanism is the termination step. Well, as soon as the whole reactant is exhausted, still in the system there are different free radicals left. So, what happens in order to terminate the reaction? These free radicals, in order to stabilize themselves, they combine with each other. And as they combine with each other, they form neutral stable species. And here's how the whole reaction gets completed. Here I have taken few specific examples of addition polymerization reaction. So this one was the first one which we have discussed, that is formation of polyethene, which happens from the reactant ethene. Similarly, here we have the formation of polychloroethene. It is very simple to remember. If you remember the reaction of ethene, it is easier for you to remember the reaction of polychloroethene and also Teflon, that we will be discussing in the further slide. So here I have chloroethene, as you can see, and I have taken it n number of times because the molecule, when I say polymer, it consists of n number of molecules. So that's why we require reactant also in n number of molecules. So as soon as this chloroethene, to which we can also call it as what, vinyl chloride, and as this vinyl chloride undergoes the formation of monomer, then that monomer repeats itself by the process of polymerization to form a polymer. And since this reactant was named as chloroethene, so its polymer is called as what, polychloroethene, or we can call it as what, polyvinyl chloride. The abbreviation for this is what, PVC. You may have heard of PVC pipes. So they are also made up of this polymer, that is polyvinyl chloride. Now the next one is Teflon. So Teflon, we prepare Teflon from this reactant. As you can see here, I have 4 fluorine. So I will write it as what, tetra. And since I have fluorine, I will term it as what, fluoro while naming. And since I have 2 carbon atom, I will write it as what, eth. And as there is presence of double bond, we will write it as what, ene. So the whole name of this reactant is tetrafluoroethene. So when this tetrafluoroethene undergoes the process of formation of monomer, then further it follows polymerization process and result in the formation of what? Polytetrafluoroethene. In general, to which we name it as what? Teflon. Teflon is nothing but the coating given in the non-stick pans and non-stick utensils. Okay. Now, with this, we have completed all the addition reaction. Now, let us start with the substitution reaction. So, in substitution reaction, we have these 3 substitution reactions, that is free radical, nucleophilic, and electrophilic. In this session, we will cover only free radical substitution reactions. Now, before going ahead and understanding what is exactly this free radical substitution reaction is, let us first understand what is the meaning of this name substitution reaction. The name itself suggests that there is something that is going to get substituted. Substituted means replacing that particular atom in the reactant, okay, or taking the place of that particular atom in the reactant. Like for example, over here I have methane, and along with that I have chlorine free radical. So I can see that this chlorine free radical has taken the place of this CH3 in the reactant. That is, it has substituted the CH3 and resulted in the formation of HCl along with the CH3 free radical. So this is called as what, the substitution reaction, where one atom takes the place of another atom in the reactant, okay, or it substitutes that group in the reactant. So this is called as what, substitution reaction. Now free radical substitution reaction occurs in case of alkanes. In only alkanes undergo free radical substitution reaction. Now let us understand why. What's the reason behind? Well, because in case of alkanes, they are hydrocarbons. They consist of carbon and hydrogen, and also we know that they have only single bonds. That is, they have sigma bonds present in them, and these bonds are very strong in nature. Now let us understand why. As you can see, when sigma bond is formed, the orbitals overlap head to head, okay, or head to tail, what we can say, or we can say end to end overlap. Now this end to end overlap is very strong, due to which the energy of the system is very low, and we know that when the energy of the system is low, this means the system is stable. This means this bond is also stable. Whereas in case of pi bond, the overlap that happens between the orbital is side by side overlap. overlap, due to which the bonding or the overlap is not that strong and efficient. Hence, pi bond is weaker than that of sigma bonds. Sigma bonds are very stable and they are very strong. So, since there is high stability of these sigma bonds, it results in the least reactivity of these alkanes. Hence, alkanes are less reactive compared to the other compounds. Now, as alkanes are very least reactive, let us understand how exactly they undergo free radical reaction. Well, when we talk about alkanes, there are two types of reactions that alkanes give. First one is the combustion reaction, second one is the substitution reaction. Combustion reaction we will learn in the future session, whereas the substitution reaction we will discuss it now. In substitution reaction, we know that some other group from the reactant gets replaced by the group which is added into it. So, since our alkanes are very less reactive, we require energy so that we can break their bonds and force them to undergo a reaction. That's why we carry out the reaction in presence of UV light. And in presence of UV light, their bond breaks and follows a mechanism called as free radical mechanism in order to undergo a free radical reaction. Now let us understand how exactly it happens. Now, when we talk about this bond breaking, because since we are providing energy to alkanes, they undergo bond breaking. So, bond breaking can be of two types. First one is homolytic fission, second one is heterolytic fission. Homolytic fission, the name itself suggests homo means same, okay, and fission means breaking. So when we have same electronegativity atoms bonded together, they undergo homolytic fission. That means their bond breaks equally, and both the species they get one electron and results in the formation of a neutral free radical species, okay. And whereas in case of heterolytic, hetero means different. So when we have atoms bonded together with different electronegativities, so when their bond undergoes breaking, bond breaks in a way that the atom with more electronegativity takes up both the electrons and results in the formation of a negative ion, and the one with the no electron results in the formation of what? Positive ion. And this positive ion is called as what? Cation, and negative one is called as what? Anion. So suppose if the electronegativity of A is more than that of electronegativity of B, then bond breaks in this way. That is, A is the anion and B is the cation. So this is how actually heterolytic fission happens, and this is how actually homolytic fission happens. But in case of alkanes, since they have atoms bonded together with the same electronegativity, they usually undergo homolytic fission. Okay. In conclusion, we can say that these two processes, they both require bond breaking because initially the compound was stable. So in order to break their bond, we have to provide them energy. But in case of heterolytic fission, since they result in the formation of cation and anion, they require more energy than that of homolytic fission. So our alkanes, they undergo homolytic fission, okay, because the atoms have same electronegativity. Now, in order for them, these alkanes to undergo a reaction, there are few conditions that we should know. So here we are discussing alkanes reaction with halogens. So there are few conditions. Firstly, alkanes react with halogens like chlorine and bromine. They require UV light because we have to provide them energy as the molecule in itself is more stable. And also here what happens, the hydrogens, they get substituted by the halogen atom. Now the question arises that why we are not using fluorine and iodine? Well, the reason is very simple. Fluorine is too reactive, whereas iodine is very unreactive. So what happens is, since fluorine is very high reactive, due to which what happens, it undergoes a violent reaction and it is very difficult to control the reaction. Secondly, in case of iodine, what happens, the reaction is reversible. So whenever we add a reactant, it results in the formation of a product, but again that product gets converted into reactant. So there is no sense of carrying out this reaction. Hence, we mostly show free radical reaction with fluorine and chlorine and bromine, not fluorine and iodine. Now let us solve one question. Which statement about the chlorine free radical are correct? First statement is it has 17 electron. It is uncharged species. It is formed by homolytic fission. Well, just now we have understood that in case of chlorine, in general, we also know that chlorine consists of how many electrons? 17 electrons. This means the first statement is absolutely correct. Second one, free radical and homolytic fission. So when we talk about formation of chlorine free radical, this is how actually chlorine free radical forms. So since we know that both the chlorine atoms, they have same electronegativity, bond breaks equally, that is by homolytic fission. So as it breaks by homolytic fission, it results in the formation of a neutral species with one unpaired electron, to which we call it as what? Free radical. This means the second statement is also correct, and also third statement is also correct. This means all three statements are correct. Hence, the correct answer is D. Now let us understand the whole free radical mechanism of alkanes. So as we discussed that in case of free radical mechanism, the first step is initiation, where we generate a reactive species. So as you can see here, I have chlorine molecule. As it undergoes cleavage, homolytic cleavage, it results in the formation of a free radical. These free radicals are very reactive, due to which they attack on the other species present in the reactant and causes a reaction to propagate. Now the next step after formation of these free radicals is to carry out the propagation reaction, where these highly reactive free radicals, they attack on the reactant molecule and result in the formation of HCl and CH3 free radical. Now this CH3 free radical is also a free radical, so it attacks on the chlorine molecules present in the system and results in the formation of CH3Cl plus Cl free radical. So this is how actually the reaction propagates. Now once all the reactant is exhausted, it's time for the termination step, where whatever are the free radicals present in the system, they combines with each other to form a neutral species, which are more stable than that of their previous state. So this is how actually free radical mechanism happens in case of alkanes, and this is how they undergo substitution reaction. Now let us solve the question 2. In the presence of ultraviolet light, that is UV light, ethane and chlorine react to give a mixture of products. Which compound could be present in the mixture of products? So well, let us first understand the question. So here we have ethane and we have chlorine, that is ethane is nothing but an alkane. So we have to show the free radical mechanism in order to answer this question. So first step is going to be the initiation step, where it is going to form free radical. So once this free radical has formed, it will undergo propagation step. Okay, so we know that this free radical, it is going to attack on the reactant. So what is the reactant that is present in the system? It is ethane. So when it attacks on this reactant, it extracts the hydrogen and results in formation of HCl plus ethyl free radical. Now this ethyl free radical is also reactive. This will attack on chlorine and result in formation of ethyl chloride plus chlorine free radical. Now this will continue till the time whole reactant gets exhausted, and once the whole reactant gets exhausted, the reaction will undergo termination, and whatever are the free radicals present in the system, they combine with each other and terminate the reaction. Okay, so that there are no more free radicals present in the system. So after doing this, here we have the mechanism. So now let us cross check whatever are the options given in the question. So here we have CH3Cl. Do we get CH3Cl in the reactant? No. Sorry, in the products? No. Do we get propyl chloride by any chance? Propyl chloride? No. Do we get butane as a product? Yes. In the last step, in the termination step, we are getting butane as a product. Are we getting pentane as a product in the product? No. So this means the right option is this butane. So this is how actually you're going to solve the question. So you're expected to you can roughly do the mechanism and you can answer these questions, because once you're aware of the mechanism, how to do the free radical mechanism, you will be able to answer these questions. Now the question 3 is, which of the following organic compound cannot be formed during the following free radical substitution reaction? So here we have ethane, which is undergoing free radical mechanism with chlorine. So we have here also we have to do the mechanism, then only we'll be able to answer this question, that which will not be formed. So firstly we will do the initiation step and then propagation and then termination. So here are the products that I have got. Now let us check these products with the options given so that we will get to know which one will not be formed, because we have to mark the one which cannot be formed. So here I can see I have ethyl free radical. Okay, this is not given in the option. Then we have ethyl chloride. Okay, so ethyl chloride, or we can say chloroethane, it is given in the question. Okay, so this is there. Then we have this one. Okay, 1 comma 1 dichloroethane, this is also there. Okay, it is formed over here as you can see. And then we have butane also in the option, but we cannot see 1 comma 2 dichloroethane in the product. So this means option A is the correct option, so you will mark this option as the correct one, because you have to mark the one which cannot be formed. Now question 4. Ethane reacts with bromine in presence of ultraviolet light to form dibromoethane and hydrogen bromide. The reaction proceeds via free radical substitution involving initiation, propagation and termination steps. What is the minimum number of free radical mechanism steps to produce dibromoethane? So you have to write the mechanism till the point you get dibromoethane and just count the number of steps you required, and then mark it, cross check with the options given and then mark the correct option. So you can write your mechanism in this way, because I have wrote my mechanism till the point I get this dibromoethane. So if I count the number of steps, it will be 1, 2, 3, 4, 5. So I require 5 steps. You can also write the same mechanism in this way, but again you will get only 5 steps required for you in order to prepare dibromoethane. So this is how actually you're going to solve this question. This means option A is correct. Now here we have the fifth question. This question is for you to try. I want you to try this question and give your answer in the comment section. If you have any query, you can also mention that in the comment section. I will surely answer. With this, we have completed our session. Thank you for watching. Do like, share and subscribe to our channel Artistic Atom. See you in the next session.